Hola, Algebra students, and welcome to the explanation of the 8.4 Practice B worksheet. I really hope that you have tried all of these problems on your own. Even if you didn't understand number 1, I hope you tried number 2. And even if you didn't understand number 2, I hope you tried number 3, and so on and so forth. Because it is very important for you guys to become independent and try to do some of this work on your own. I made this video in case you have specific questions. This video is not meant for you to just watch the whole thing and copy all my work. This video is supposed to be for you to check your work. Okay, the directions said, solve by factoring if possible. Remember that it is very important to make sure that all your terms are on one side of the equal sign and that on the other side you have a 0. The 0 could be on the right side or it could be on the left. The important thing is that your leading coefficient should be positive. Okay, so it's really important to always make sure that your quadratic term is positive. Okay, in number 1, the leading coefficient, the quadratic term, is already positive. This is a quadratic trinomial, so I'm always going to check for GCF first. 1, 19, and 90 only have a GCF of 1. So then I continue to the next step. This is a quadratic trinomial, so I'm going to try to find two numbers that multiply to the outside numbers, the coefficient of 1 and 90. So 1 times 90 is 90, and I'm going to write all the factors of 90 and see which ones I can use to replace the 19. Now, 90 is a pretty long list. So hopefully you took your time. If you have not done this problem, I want you to pause the video and finish writing all the factors of 90. Push play when you're ready. The pair that would work are the numbers 9 and 10. There are no negatives in the original problem. I can use a shortcut since the leading coefficient is 1. So give me just 1 second, guys. Okay, so this would factor to x plus 9 and x plus 10. Then you set each factor equal to 0 and solve. So your two solutions would be negative 9 and negative 10. Okay. The next example has terms on both sides of the equal sign. The first thing that I check is the quadratic term. If there are quadratic terms on both sides, I always move the smaller one. Or whichever one has the lesser value. If you're not sure, look at the coefficient. So you have a negative one and a positive one. On a number line, positive one is more to the right. The negative one is more to the left. The smaller one is always more to the left. So you can't just move it with magic. You have to move it by canceling. So I'm going to go ahead and, since it's a negative 1m squared, I'm going to add 1m squared. That gives me 0. And I'm going to combine it with a like term on the other side. Bring down the 5m. I have 4m plus 2m squared. Now, we already decided to move the quadratic term from the left side, so I'm also going to continue with that idea, move everything else that's on the left and move it to the right with its like term. Now I have the 0, I have negative 1m plus 2m squared. I'm going to go ahead and rewrite this in standard form so that my quadratic goes first, then my linear. It is really important for you guys to make sure you're always writing your quadratics in standard form. Standard form means you write it from biggest exponent to smallest exponent. So quadratic, term first, then linear, and then constant if there is a constant. Okay, the directions were to solve by factoring if possible. This is a binomial. I always need to check for GCF. Even though 2 and 1 have a GCF of 1, they both have a variable m as a GCF. So I'm going to go ahead and factor out the m. That would leave me with 2m minus 1. Remember, any number divided by itself equals 1. Then I'm going to ask myself, because this is a binomial, can I keep going? Is it a difference of squares? It is a difference, and 1 is a square, but 2 is not a squared because when you square root it, you get a decimal. Also, the variable m is not squared. So I am done factoring. I'm going to set each factor equal to 0. This one is easy peasy. When I set it equal to 0, there's nothing to cancel. That's just a solution. This one you'll have to cancel the subtraction with addition, and then divide by 2. Reduce if possible. 1 over 2 does not reduce. So your answers are 0 and 1/2. In the next problem, you have variables on both sides. Look at the quadratics. If there are quadratics on both sides, you're going to move the smaller one. Cancel the smaller one. But remember, you can't do it with magic. You have to do it with opposite operations. So this is a negative 1k. I'm going to add 1k. That will eliminate it. Sorry, 1k squared. On this side, you'll have 4k squared plus 2k minus 3. We already decided we're going to move all the terms to the right side. So I'm going to keep going using opposite operations. So this is a positive 3k. I'm going to subtract 3k, keeping like terms with like terms. Once you have that 0, you're ready to try to see if you can factor. There's no GCF for these three terms, but it's a quadratic trinomial. So I have to try to find two numbers that multiply to negative 12 and add to negative 1. So if you haven't done so already, pause the video now. Find the two factors of 12 that will multiply to negative 12 but add to negative 1. Push play when you're ready. Okay, I'm going to split the middle here because the leading coefficient is not 1. I'm going to separate the negative 1k into a positive 3k and a negative 4k. So notice these two are the same as negative 1k. If I wanted to combine them, I could. Okay, I'm going to take the GCF of the first two, GCF of the second two. This would be 1k. This would be negative 1. And you have your GCFs and then your remainders. So your GCFs were 1k minus 1. And then the remainder, if I divide these or these, should be the same answer. You should have 4k plus 3. Okay, set each one of these equal to 0. And your answer should be 1 and negative 3/4. Okay, in the next problem, I'm going to look at the quadratic term. There's no other quadratic term. I already have a positive quadratic term, so that means I'm going to keep it there. That means that everything on the right side needs to move to the left. Remember, you always want to keep your quadratic term positive. If you have quadratic terms on both sides, move the smaller one. This one had a quadratic term that was already positive, so I'm going to leave it there. That's the left side, so I want everything else to be on the left side. Combine like terms. Don't stop until you get a 0. And now you're ready to factor. If you haven't done this problem yet, please pause the video, check for GCF, and then see if you can factor this. Push play when you're ready. Okay, you may have thought that the two numbers that would work would be 6 and 4. However, no matter how many different ways you try 6 and 4 with either a positive 6 and a negative 4 or a negative 4 and positive 6, both positive 6 and positive 4, both negative 6, both negative 4, you get the idea. It'll never work. You have to use 2 and negative 12. Those are the only two factors that will add to negative 10 and multiply to negative 24. Since the leading coefficient is a 1, I can use a shortcut for factoring it into w plus 2 and w minus 12. Set each factor equal to 0, and your solutions will be negative 2 and positive 12. Okay, number 5 has terms on both sides as well. But if you look at the quadratic terms, here you want to move the smaller quadratic term, because you always, by moving the smaller one, you guarantee that your quadratic term will be positive. If I would have moved the 3x squared instead, I would end up with a negative quadratic term, and I want to avoid that as much as possible. So I'm moving all the terms to the left side. You can do it one by one, or you can cancel both at the same time. Just make sure you're keeping like terms together. Okay, if you notice, the 4x's cancel on both sides, and we're left with a binomial. Always check for GCF. 9 and 36 reduce to 1/4, which means that their GCF is 9. If I factor out the 9, I'm left with x squared minus 4. This is a difference of squares. X squared minus 4 can factor even further into two binomials, one with addition, one with subtraction. You can square root x squared, you get x. You can square root 4, you get 2. And that is the final factored form for number 5. The solutions, however, come by setting each linear factor equal to 0. This is not a linear factor. If I set it equal to 0, it doesn't make sense. 9 can't equal 0. That's a constant term. You don't set constants equal to 0. You only set linear terms equal to 0, or linear factors. So since both of these have x to the first power, that's linear, these can be solved. So your answers are negative 2 and positive 2. Okay, the next problem has quadratic terms on both sides. I'm going to cancel the one that's on the right side because that one's smaller. And remember to keep like terms together. So n squareds with n squareds, quadratic terms with quadratic terms, linear terms with linear terms. So that 5n, when I cancel it with a negative 5n, I'm going to combine it with the 9n that was on the other side. Okay. As soon as you have set your quadratic equal to 0, you're ready to factor. Right away I notice that all of these numbers are even, so I'm going to check if there's a GCF for all these. 4/8 reduces to a half, so the GCF there is 4. 4/24 reduces to 1/6, so the GCF there is also 4. So it's safe to say that all of these can be divided by 4. The GCF is 4. That would leave me with 2n squared plus 1n minus 6. But wait, GCF isn't the only way we know how to factor quadratic trinomials. Take a look at what's left inside. We need to try to see if we can find two numbers that multiply to negative 12 and add to 1. If you said negative 3 and 4, you're correct. So I'm going to go ahead and bring down that 4 so I don't forget it, and focus on splitting the middle term here to a negative 3n and a positive 4n. I'm also going to bring the 0 down. I'm going to find the GCF of the first two terms and the second two terms. So my factored form for this quadratic trinomial is n plus 2 and 2n minus 3 with a 4 in front. But remember, for solving, it doesn't make sense to set the 4 equal to 0. You can set this one equal to 0, though. I ran out of room there, so I'm going to do it over here. N plus 2 equals 0 would give you an answer of negative 2. And 2n minus 3 equals 0 would give me an answer of 3/2. Number 7 only has one quadratic term. It's already positive, so I'm going to leave it there and move everything else to that same side, the left side. Make sure you're keeping like terms. So remember, on this side, it's a negative 9x. You want to make it a 0, so you have to add 9x in order to cancel it. Then bring down the negative 6. Notice there's a subtraction in front of it, so that means that it's negative. To get rid of the negative, you're going to add a 6, and I'm going to squeeze it in here because that's a constant. Make sure you don't combine the 6 with the 21x or the 6x squared because that's a constant term. Now that it's set that your quadratic is set equal to 0, you're going to try to factor. Always check for GCF. Siempre. I notice that all of these are divisible by 3. So I'm going to go ahead and divide them by 3. That leaves me with 2x squared plus 7x plus 2. Then I'm going to see if I can keep going. This is a quadratic trinomial. I'm going to try to find two numbers that multiply to 4 and add to 7. Well, super sad. The only factors of 4 are 1, 4, 2, and 2. None of those will ever add to 7. So unfortunately, I cannot keep going and I can't solve by factoring because this cannot be factored. So my solution, I cannot find the way they asked me to. It does have a solution. I will teach you how to do it, but for now you're going to say can't solve by factoring. If you guys have any questions, feel free to send me a message on Remind or email me or send me a message on Google Classroom. Good luck, guys. See you soon.